I am starting the special casting techniques, that is the unit 2, and under unit 2 what is the outcomes, unit 2 outcomes. At the end of this unit 2 the student will able to learn the demonstration of various special casting techniques. So under this unit, what are the contents? First content is molding sand, preparation and composition of the molding sand, sand property test, casting checkout, core type of cores, and also core print, chaplets, chills, exothermic materials, application in sand casting, and metal fluidity. That is the first part of that content, molding sand. Furnace, also we will discuss different type of furnace that will be used for making the molten metal using different metal pellets. So what are the furnace, different type of furnace? Cupola furnace, crucible furnace, cupola, induction furnace, reverberatory furnace, open hearth, arc furnace, and also we will discuss about the casting design considerations. Another third number, solidification of the casting, concept of the solidification of metal and alloy, and also problems on solidification time also we will discuss. Another, special casting process. What are the special casting process? Centrifugal casting, die casting, investment casting, cell molding. That are the different types of special casting process we will discuss. Another, casting defects. Also discuss what are the causes and what are the remedies of that defects which will created during casting time. In case of first one, we will discuss about the molding sand under unit 2. In case of molding sand, what are the contents, means what are the outcomes, learning outcomes of that end of that lecture. What are the outcomes? Means student will able to learn the preparation and composition of the different sand and sand property test, casting checkout, and types of core prints, chaplets, chill, and exothermic materials applications in sand casting, and also learn about the metal fluidity. First one, molding sand composition. So what are the main ingredients of the molding sand composition? First one, base sand, binder, and moisture. That is the main ingredients of the molding sand. Okay, that major component of the molding sand, it is easily available in the river beds. Okay, means base sand is the generally green sand, means to the sand the moisture or clay will be mixed to that particular sand, and that is used for making mold. Means sometimes we have used some other type of sand, that is the zircon sand, chromides, olivine sands. That type of sands also we have used for special casting processes. Okay, silica sand, that is easily available in the nature, and also cost of that sand also less. The characteristics of that base sand is sides is some distribution effect that control the surface finish of the particular product. Okay, and also that type of sand maintain some properties also, means permeability properties, refractory properties, that type of properties also maintain to of that particular base sand. Okay, now natural and what is synthetic mold sand. In case of natural sand, 65.5% silica grain which is available in the nature, and another is 21.7% clay content, and 12.8% is the undesirable impurities that will be mixed to the natural molding sand. So always when we use that sand, so always we try to remove the undesirable impurities. Okay, that maybe deteriorates the quality of the product. Synthetic sand, that is the made by mixing specially selected high quality clay free silica. Actually that is produced by using some equipments. Manually we have prepared that synthetic sand, means that sand is a high quality clay free silica. Near about 5% clay is remaining there, otherwise no clay is there. Okay, only particular sand is there, that is called synthetic molding sand. Now what are the binders used in sand casting? So that is the important things that will help to produce the casting process. Okay, so main thing we know sand is there, but for editing, for binding of that sand, some extra materials are required. First is clay, fire clay. Okay, southern bentonite, that is acts as a clay, and another is western bentonite, secondary mica clay. That things are used as a clay. All things are acting as a binders. Another oils, sometimes we use vegetable linseed oil. Another is marine animal like whale oil. Okay, another mineral, that type of oils also used as a binding material. Another is synthetic resins or thermosetting materials. What are there? Now urea formaldehyde, phenol formaldehyde, that act as a synthetic resins. Then cereal binders made from the cereal binders, that will be made from corn. Okay, so gelatinized starch, that is also acting as a binder materials. Another is gelatinized corn flour. Okay, another is dextrin, that also used as a binder materials. And also wood product binders. What are the wood products? Natural resin, that also acts as a wood product binder. Sulfite binders, water soluble gums, resins, water soluble gums. Okay, resins, organic chemicals, that also acting as a binders. Another protein binders, glue, casein. Okay, another other binders, Portland cement, pitch, molasses, cement, sodium silicate. That will be all things, means clay, oils, synthetic resins, thermosetting materials, cereal binders made from corn, wood product, protein binders, and other materials like molasses, cements, pitch, Portland cement. Everything acts as a binder material. Okay, so how they will backing, means hardened by the backing, that is the hardened by the backing, or that will be hardened at room temperature. Okay, and available as either a liquid or dry powder. That all things are available as a dry level or powder level, or maybe liquid level available of that particular binder things. Now binders are many types. Binders generally many types, maybe clay binders, maybe organic binders, or maybe inorganic binders are available. Generally clay binders mixed with the binding agents. Okay, means that will be mixed with the molding sand. Okay, so to increase the strength of that particular molding sand. The most popular clay types are kaolinite or fire clay, that is called fire clay sometimes, and also bentonite. That are the most important, fire clay or bentonite, that is the most important clay binding materials. Okay, generally we have used naturally in the casting process. Amongst these two, the bentonite can absorb more water, which increases the bonding power. Bentonite solution, it absorbs the more water, and also it increases the binding strength also. Now moisture, one of the important part of the molding sand, that acts as a binder to the particular molding sand. Okay, moisture is the form of water coats surface each flake of that clay. Okay, means when we are taking the moisture or water vapor, that is called water vapor also, sometimes that will be mixed with the clay and it will makes the plastic type materials. Okay, means molten type materials. So it will help to produce the act as a binding material to the particular sand materials, and also it increases the binding capacity, binding strength. So what is the molding sand composition? Weight percentage, silica sand weight percentage is 92, clay sodium bentonite weight percentage 8, and water percentage, that is the moisture, that is the 4%. That is the typical composition of that particular molding sand, 92, 8 and 4. Molding, what are the molding material properties? So using molding material, some particular properties are there. Means based on that properties we have used that molding materials. First is refractoriness. That molding materials has capability to withstand the higher temperature. Means when we pouring the molten metal to the particular mold cavity, its temperature is very high. So for withstanding, for sustaining the higher temperature, so molding sand is required. Generally at silica has higher melting point. So that's why it maintains the refractory properties. Permeability. When we pouring the molten metal to the mold cavity, so in that time the vapor or pores, means heat will be extracted when it will come to the mold surface. The gases will be formed to the mold cavity, and when gases or water vapor or moisture will be created, it tries to come out of the mold cavity. If it will remain to that particular mold cavity, it creates the gas porosity problems. Means it will try to acquire the some space, and due to that thing the problem will be occur to that particular mold cavity. The quality of the product also deteriorate. So if we use the fine molding sand, so it has some passage, and due to that passage what happens, now easily the gases will be come out, or air will be come out easily from that particular mold cavity to the air, and due to emerging of that air, so what happens, the no gas bubbles, no gas porosity problems occur to that particular mold cavity, and due to emerging that gases, the quality of the product, a final product or mold cavity will be produced. That property is called permeability property. Green strength or cohesiveness. Green strength means to the molding sand the moisture is available. Means clay, some extra parts, means some binding materials, that is the moisture or clay will be present to the molding sand. That helps to binding the molding sand properly to in case of casting process, and the strength will be present to the green strength conditions. Means green strength condition, the strength of the green sand at that particular green sand, so that will availability to the green sand condition, that strength is called green strength. Means the strength of the green sand, that is called green strength. Okay. What are the adhesiveness? Adhesiveness means the attraction of the different particles. Means here molding aggregate should have to property getting cling with the surface of the molding. Means molding sand attracts to the molding boxes. Means here particles of different parts, not same parts. So in that cases, that is called adhesiveness. Means attraction of the different particles, that is called adhesiveness. Cohesiveness means attraction of the same particles. So that act as a cohesiveness property. What is a dry strength? Means the strength of the dry sand during casting process, that is called dry strength. Means here no clay is there, no moisture is present to that particular sand. Means when we provide the heat or provide the liquid metal, the moisture or clay type means water vapor, it will be removed. Collapsibility means when molten metal starts solidification, it will contracts. Means metal starts solidifying, it will contracts. Means some extra allowances will be created. Okay. And also the molding sand should not hinder to that contraction of the metal. Okay. The molding sand means, that is very important. Molding sand should not hinder to the contraction of the metal. Otherwise, if it will hinder, the produced part will be crack. Means the cracks will be casting may arise. If sand material will be present to that particular mold cavity, the finished product, the produced product takes some cracks. So always we remove the molding sand from the casting product. Means the molding sand should not hinder to the contraction of the metals. Otherwise, the cracks will be formed to that particular product. So to avoid that hindrance, the solidifying of metal, the molding sand should possesses high collapsibility property. Means molding sand has high collapsibility property. Means after casting process, we easily broken the molding sand. Okay. And after broken of the molding sand, then we remove, means we separate the other parts. Pouring basin, sprue base oil, runner, gate, riser, everything we will be separate. Then after separating that thing, finally we have taken the final casting product. Then we are taking some cleaning operations, inspection operations, something we have done. Okay. Now we are taking some testing process, compactability test, Setter index and compression strength and permeability in grain sand. So how we test that things? That is the important. First, for doing the compactability test, so we are taking a metric sand rammer. Okay. So after that, the decrease means we provide some a 120 millimeter height is there, and under that height we provide some sand rammer. Means we provide the pressure to that particular formation of the molding sand. Sand type means that is the cylindrical type sand we have produced. Then after that we provide the pressure. Then it will, that height of that particular cylindrical type sand, that will decreases. Okay. And based on that, the degree of temper of a sand can be measured. And and also we determine the water requirements in that particular molding sand. What are the testing procedure in case of compactability green sand? First, position of a specimen tube or pedestal cup on the tube filler. Okay, just filler beneath the funnel outlet. Then pass the sand to be tested through the screen. Okay, until the tube is filled up. Means up to filling of the tube, then we passes the sand. Then trickle the sand level with the top of the tube. Means after filling of the tube, then we level by using some extra things, extra part, we level that particular tube. We particular up to that level, the sand will be filled up. Okay. Then remove the specimen tube and pedestal cup and place in the position on the sand rammer. After filling that part, we remove the specimen tube and pedestal cup and it will be positioned to the sand rammer. Then lower the plunger gently onto the sand and ram with 3 blows. Okay, means after filling that rammer, we providing the some pressure to that particular sand rammer, and then it will properly ram to that particular cylindrical part. Finally, reed percentage compactability as indicated by the position of the top of the plunger shaft on the scale. Means after ramming, sometimes the sand may be coming to that position. Okay. Then using the scale, we have determined the compactability percentage. Means after ramming, here position is there of the molding sand to that particular tube. After ramming, it will come maybe in that particular position. Then using the scale, or some measuring instruments, we find out the percentage compactability. That is the testing procedure of the compactability of green sand. That is the picture. What happens in that particular picture? Now that is the funnel part. Okay. And through that funnel part, we use some tube type part. Okay. And that using tube type part, we through that funnel, we providing the molding sand, and some strainer is there, and in that strainer the impurities will be extracted to that particular molding sand. Then that type of tube is there, and in that tube it will be filled up to that position. It will be filled up in that particular position. After taking that thing, that is the rammer, means sand rammer. Here it will be placed in that particular position. It will be placed in that between to that particular position. Okay, it will be placed. After placing that tube, it will using that ramming, it will give the pressure. After giving the pressure, the percentage of compactability is there, some indication is there. Using that indication, finally we have tell that after ramming, what is the percentage of compactability? Maybe 30, maybe 40, or maybe 50. That will be measured by using that scale. Now, determination of the shatter index of green sand. How we will find out the shatter index? First, we are taking a standard specimen, 50 millimeter diameter and 50 millimeter height, means as like a cylindrical type shape. Cylindrical type shape means here diameter is the 50 millimeter of the standard specimen, 50 millimeter, and height is 50 millimeter also. Height is also 50 millimeter. Okay. So molding sand is allowed to free fall from the height. What is the height? 1.83 meters onto a steel anvil. Then weight of the sand receiver, and calculate the weight of sand remaining to that particular receiver on the ship. Means after falling of that particular molding sand part specimen, means standard specimen, height specimen, after falling, then some amount of material will be kept to that particular receiver. Based on that, we taking the weight of that particular remaining material to that receiver, and based on that, we taking the shatter index, means weight of sand remaining on 13.2 millimeter mesh size by total weight of sand specimen. Means total what is the sand specimen? 50 millimeter diameter into 50 millimeter height. Means that is the total weight of that standard specimen, and then remaining sand to the particular ship, means receiver. Then we are taking the weight of that receiver. Receiver means ship, and ship mesh size. The mesh size of the ship is 13.2 millimeter mesh size ship. So on that particular mesh size ship, what are the remaining weight of that particular molding sand material? We find out, take the weight. After taking weight, that is weight of the sand remaining on 13.2 millimeter mesh size ship into 100 by total weight of the specimen. Using that thing, finally we have find out the shatter index. That is the picture. Means here the height of that, here we kept the standard specimen, okay, and here ship is there. the height is 1.83 millimeter. Here height from that space to that distance is 1.83 meter. Okay, so from that height we fall that standard specimen to that particular sieve. The mesh size of that sieve is 13.2 millimeter. 30.2 millimeter mesh size sieve. So after falling of that standard specimen, some material will be remaining to that particular sieve. Okay. After remaining the particular some materials, we are taking the weight of that particular remaining material. Based on that, we taking weight of that remaining material, taking weight of remaining material, taking weight of remaining material. Taking weight of remaining material which is present on the 13.2 millimeter mesh size sieve, then into 100 remaining weight WR into 100 by total weight. Total weight, that is called Sator index. In that way we measure the Sator index. Now we are coming determination of the compression strength of the green sand. How we measure the compression green strength? Determination of compression strength of the green sand. First, we are taking the specimen, standard specimen, 50 millimeter diameter and 50 millimeter height. Okay, and that will be measure the compression strength using compression strain machine. Using compression strain machine, we measure the compression strength. Then the machine is designed to determine the compression strength of the standard specimen, okay, which is made by the green sand. Okay, and using that sand, that specimen will place one position is there to the compression strain machine. We position to that particular position. Then we provide by applying progressively increasing spring load to that particular specimen until it collapses. Until it collapses, we providing the increasing load. Okay. After taking the collapsing or cracking to that particular material, we have noted down to the dial of the machine what is the compressive strength. Before collapsing, we kept that standard specimen to that particular material. Then we providing the load. After providing the load, it will take some collapsibility or it will take some crack happens to that particular specimen, and after cracking we will take the what is the scale to that particular dial. We noted down, means that is the final compressive strength of that particular green sand. Means that is the compressive green strength machine. So that is the called compressive strength machine. So in that machine what happens, now we kept the particular standard specimen here. Okay, standard specimen we kept in that particular position. After keeping the standard specimen, we providing some load, increasing some loads. After increasing the load, that specimen maybe take some cracking. Okay, after taking the cracking in that particular specimen, in that time we taking some noted down the scale in that dial. Means on which load it will take cracks or collapsibility. So in that particular scale we will note down, and that is the compressive strength of the green sand. What is the permeability of the green sand? How we will measure the permeability of the green sand? So permeability is defined by the American Foundry Society. Okay, one standard formula will be formed by the American Foundry Society, that is the physical property of the molding sand which allow the gas to passes through that particular molding sand. And it will be determined the rate of flow of air through the metric standard ramped specimen under a standard pressure. Means one standard specimen I have taken and it will be ramped properly. So after taking that standard specimen, in that particular specimen, we measure the flow of the air. So how we will measure the flow of the air means what is the permeability of the standard specimen, means after ramming one standard specimen will be created. So in that cases what formula we have used? In that cases we use P equals to V into H by P into A into T. Using that formula we have measured the permeability, where P is the permeability number, P is the permeability number, V is the volume of air in milliliter passing through the specimen, means volume of the air in milliliter passing through the specimen. Another height of the specimen. So standard specimen maybe we will take 50 millimeter height and diameter will be 50 millimeter. Okay, and P is the pressure of the air in semi of water. Okay, then area of the cross sectional of the specimen maybe it will take in centimeter square, and T is the time in minutes. Using that formula we measure the permeability of the green sand. That is the photograph of the permeability meter, and using that permeability meter we can measure the permeability of the green sand. Casting shake out. What is the casting shake out? So in that cases one new product will be produced using the casting process, and after production, after solidified of the product, so what happens now, sometimes for taking the product from the particular molding box, first we some sack or wrap the product, means some extra spaces will be created to that particular molding box, means after removal of the box part, means scope and drag, then we remove the some extra part, means screw, runner, riser. After removal of that part, some extra part will be removed, some extra space will be created, and easily we remove the final product, means due to creation of extra space we easily removed, means other parts will not affect it. Okay, that is called casting shake out. Means what happens when a casting is first pulled, steaming from the mold, it is covered in sand debris and some other impurities are there, metal, it must throw the shake out, and due to shaking sometimes what happens, some debris, some other parts will be removed from the final product. Okay, and cleaning, gate, riser removal, finishing machines which make a bone shaking racket as they do their work, and in that cases also we have seen that final shape will be, we are getting the final shape, means removal of the debris due to shaking in that particular product. Means powder coating, inspection may still necessary before shipping, means before taking the final product, that type of things, means some heat treatment, some powder coating, means inspection, means cleaning, inspection, finishing, that type of things are required before shipping. What is the remove the casting from the mold? Remove the casting means the process of removing the casting from the mold, beginning with determining right time and temperature to the shake out. Means after formation of the final product, in that cases we taking the final product from the molding box. Okay, so final product production, we remove the some extra parts, means from the molding box we remove the some extra parts, means screw, runner, riser. After removing that things, finally we are taking the final part, and after taking the final part we are doing some finishing operation, inspection operation, means cleaning operation we have started. Then sand casting, unmolding sand casting is called shake out, means when some sands sometimes stick to the particular product and due to sacking some sand particles will be removed from the final product, means some finishing will take place to that particular product. Okay, and so in that cases we are getting the finished product due to sacking. Another, removing of sand cores, means after solidification then we remove the sand cores, means sometimes we use sand cores for creating the internal features to that particular product. So removing the mold, then means molding box, some other parts will be removed, then we remove the sand cores. Okay, then after removing the sand cores, finally we have got the product. Then we are starting the cleaning, means casting do not come finished from the vibrating table, they must be cleaned in a process. Traditionally it is called fettling in case of casting process, means in that cases we are seeing that also be remove the riser, runner, gate, sprue base oil, we remove that part. After removing that part, finally we have got the final product, and in that particular product we are doing some cleaning operation. So we flushing is a common small imperfection of sand and die casting. So we are sometimes doing flushing operation for finishing purpose. Okay, primary cleaning, in case of primary cleaning we are using some, means using primary cleaning, so strip of scale, flushing, bars, other impurities we will remove using air blast machines. Okay, in case of sometimes we have used pneumatic hammers, drills are commonly used for sand core removal. Sometimes sand core removal we are used some pneumatic hammers or drills. Removing, after that some we use water blast process. It most simple from pressure washing of the casting. Hydroblast, that also we use for remove the some abrasive type particles from the final product. Removing the gates and risers, after that we remove the gates and risers. Sometimes some gate and risers, sometimes it will stick or attach to the final product. For removing that gates and risers, sometimes we use chipping hammer or sledge we are used. Sometimes we use for oxyacetylene torch for removal of that particular extra gates and risers. So some extra parts we have used for removal of the some gates, risers, some other parts. And machining, finally for getting the final finish or for getting the very fine finish or getting the for good surface quality, we do the some machining operations. Machining operations, maybe we have used turning, grinding operation for getting the final finishing or for getting the accurate dimension to the particular product. Nearing the end of the line, means that is the end of the sack out, cleaning and machining. The casting is in the final form, means the end of the line of the casting process. So in that cases we are seeing that further finishing touches might still be necessary, including sometimes some final and accurate finishing. Sometimes we are using some other processes, heat treating, painting, powder coating or assembly. That type of thing also we have done after final finishing. Okay, so means finally we have prepared for final shifting of that particular product. Core, what is core? Core is a device used for casting and molding process to produce internal cavities. Core always used for producing the internal cavity to the casting product. Okay, or retrent angles, means interior angles we have produced using cores. Sometimes that greater than 180 degree. Core is normally disposable item that is destroyed to get out of the space. Means after production of the internal features, we remove the core parts. What are the type of the cores? type of the cores, that will be depends upon the different factors. According to the state of the condition of the core, first is green sand core. Green sand core, that is the part of the mold, and green sand core made out same sand from which rest of the mold has been made. Means just using same sand, using that sand we prepare the green sand core. Another dry sand core, that also unlike green sand cores. Dry sand means here no moisture or water vapor does not present to that particular dry sand core. Using dry sand cores sometimes differ from the other sand. Okay. And dry sand cores are made separately and independent of that mold. Means dry sand core are made separately. Another, dry sand core is made in core box and backed after ramming. Means it will be backed to the, it will made to the core box and it will be rammed properly. Another, according to the nature of the core materials used, first is well bonded cores. Sometimes conventional sand cores are produced by mixing silica with small percentage of linseed sand. Okay. Another, resin bonded cores, that will be sometimes phenol resin bonded with sand with rammed in a core box. Another, the core is removed from the core box and backed in a core oven at 375 to 450 to harden to the core. Shell cores made of manually or on machine, and that produced making shell cores is as follows. The core box heated to a temperature near about 400 degrees centigrade to 600 degree Fahrenheit. 400, it will be heated up to 400 degree to 600 Fahrenheit. Another hot, according to the type of core hardening process, first one is hot box process. So in that cases, heated core box will be used for production of the cores. And another, the core box maintain the temperature near about 350 to 500 degree Fahrenheit. And in that cases also we have seen that heated core box is employed, heated core box we have used for producing the core and maintaining the temperature 350 to 500 degree Fahrenheit. Another, the cold set process. Here for producing the cores we have maintained generally room temperature, means cold set process, means extra heat we will not provide to that particular process. A little heating, maybe sometimes a little heating will be required in that process. Okay. Cold set process is preferred for jobbing productions. Means in case of job production, means that is the mass production. In that means job production means here product will be prepared, product will be manufactured as per specific order. Okay, that cold set process will be more useful in case of jobbing production. And according to the shape and position of the core, that is also some types. Another is horizontal core. Means here what happens, core, that is the core will be placed horizontally. Okay, that is the mold cavity. Means here the core will be provided horizontally. Means some part, half part will be upper part of the drag side. Means some part will be cope side and some part will be drag side. Means cope part means that is the upper part of the molding box. That is the horizontal core. And in case of vertical core, the core will be placed vertically. Okay. The position and shape of the core will be divided. Means some core will be placed to the horizontally and some core will be placed vertically. Another is hanging type. Means here position of the core means that if it is a parting line, so position of the core will be as like hanging. Means cover type, as like hanging position or cover type position. Another is dropped or stop up core. The position of the core as like drop or stop up the position of the core in that particular molding box as like drop or stop up type. Okay. Here balance core. In case of balance core, we are seeing that if it is a parting line, if it is considered as a parting line, the half part of the core will be upper side and other half part will be placed to the lower part of that particular molding box. Means it is as like balance core. It acting as a balance core. Okay. Another ram up core means shape of that particular core is a ram type. Is a ram type, means shape are seeing that as a ram type, and it will be placed to that particular molding box. Okay, means that shape are seeing as a ram type core. Okay, what are the requirements of the core? Means some requirements are there. The green condition there must be adequate state for handling. Dry, we do not use dry sand. We use the green sand, means the sand will be mixed with the some clay or moisture. So in that cases it will maintain the higher strength and it will be suitable for handling of that particular sand. Another permeability must be very high. But why it is required? For escaping the inside gases or inside generated gases or inside air. Another, the casting or molding cools the core must be weak enough to break down as the material shrinkage. So, in that cases, the molding sand must be cooled. Okay, means easily it will be cool. Otherwise, the pouring molten metal, when extracting the heat from the pouring molten metal, it will come to the mold surface. Mold surface, after coming the mold surface, the heat will be extracted from that through the green sand. So it will also the capability of the green sand also required for removing the heat. Another, good refractoriness is required. Means molding sand materials has good refractoriness capacities. Means it withstand the higher temperature. When pouring the molten metal, its temperature is high. So in that cases, the green sand also required the withstanding the higher temperature. Smooth surface finish, also green sands provide the smooth surface finish to that particular mold product which is produced by the casting process. A minimum generation of the gases during metal pouring. When in that time, sometimes minimum air will be entrapped or minimum gases will be generated. When pouring the molten metal, it will take the heat and sometimes vapors will be created. Okay, means minimum generation of the gases also created when pouring the molten metal. So that is the requirements of the core. Core print. Why we use the core print? Core print is provided to the open spaces in the mold for locating, positioning and supporting the core. Why we use the core print? Core print is provided for supporting, positioning and locating the core. That is the main use of the core print. That is the core print. If we are seeing that picture, so we are seeing that is the core print. Okay, means if we consider that is the core, we are considering that is the core, so that core prints helps to for positioning, locating and supporting the core to that particular mold cavity. That is the main function of the core print. Why we use the chaplets? What are the small metal insert or spacer used in molds to provide the core support during the casting process? Chaplets will be used for supporting the cores. For supporting the cores means small metal insert or spacer will be used in the mold cavity for supporting the core. Okay, that is the main use of chaplets. What are the use of chill? Chill will be used for directional solidification. It will help to extract the heat from the pouring metal. Means easily it will help to remove the extra heat from the pouring molten metal. That is the main use of chill. Means it will be used for directional solidification throughout the castings. Mean it will help to removing the heat or chilling equally from the throughout the casting. Okay. That is the chaplet, means if it is act as a core, so that are the chaplets, means it will help to support the core material. That is the main use of that chaplets. Okay, that is the cavity and that is the parting line. Upper part is called cope, lower part is called drac, and that is the mold and that is the mold cavity. That is the mold cavity. Mold cavity. Some exothermic materials we use in sand casting. Why we use some exothermic materials? Means sometimes we use exothermic materials for maintaining the fluidity of the molten material. If we are keeping some extra material or storing the extra material to the riser, maybe it will freeze. So it will maintaining the fluidity of that molten metal condition. So we using some exothermic materials, means we provide the extra heat using that material, means it will maintain its fluidity property. Otherwise maybe it will freeze, means it will take some solidification. If it will take solidification, it does not flow to the particular cavity when it will create the extra space or extra allowances. When metal will take shrinkage, it will does not flow. So for maintaining the fluidity, for maintaining the molten condition of the metal, we using some exothermic materials in the sand casting process. What are the metal fluidity? Metal fluidity means the pouring temperature, a particular pouring temperature is there. At that particular pouring temperature, it maintains its fluidity, means it will maintain in molten conditions. Otherwise, it will when flow through the gating system and it comes to the mold cavity. Before coming to the mold cavity, it will take solidification. Means what happens? The capability of the molten metal to fill mold cavity is fluidity. Okay. The term consists of two factors: characteristics of molten metal, another is casting parameters. So what are the parameters which affect the influence of fluidity? First, viscosity. Viscosity always is less amount of viscosity is required. Means we increase the temperature, fluidity decreases. Means if viscosity increases, so fluidity increases. If we increases the temperature, so in that cases fluidity will be increased. Surface tension. High surface tension of liquid metal reduces also fluidity. Okay. Inclusion. Some impurities will be added to that particular molten metal. So in that cases also decreases the fluidity. How to measure the solidification of the alloy? Fluidity is inversely proportional to the freezing range. Means after pouring the molten metal to the mold cavity, it will take the solidification. So if maintain the higher fluidity, so it will easily goes to the particular mold cavity. Means if it will take solidification, it does not maintain the fluidity properties. Means inversely proportional to the fluidity range. How to test? We use some spiral in the fluidity index. We have used that type of fluidity index used. We pouring the molten metal through that particular fluidity index. It will through that is the pouring cup and that is the sprue, and through that sprue it will come to that particular spiral shape is there. Means up to that shape, means after coming to that particular point, it will take solidification. Means up to that point we call that is the fluidity index. Okay. Means what happens? Although none except in universally several tests have been developed. So one such test shown in figure, molten metal is made to flow along a channel at room temperature. The distance of the metal flow before its solidification and stop is a measure of its fluidity. Means after coming to that particular point, we measure the distance. Means we can say that is the measurement of, means that is the fluidity of that molten metal up to that point. Okay, of that particular metal also, molten metals also. Okay. Means the greater length of the solidified metal, the greater is the fluidity. The greater length of the solidified metal, it denotes the greater fluidity of that particular molten metal. And what is the concluding learning outcomes in that cases? We see that end of this lecture, student have learned preparation and composition of the molding sand, sand property, test, okay, casting sack out, types of cores, core prints, chaplet, seals, exothermic materials applications, and in sand casting and metal fluidity. That thing has learned in that particular lecture. We will see one video, determination of sand preparation and sand reamer base block compatibility tester. 50 into 50 millimeter specimens preparation. First we are taking some sand and it will put 13.2 millimeter sieve size. We pouring the sand material, and that is the tube type, and in that tube we are taking the molding sand. Okay, we are taking the molding sand, and then using the rammer we prepare the standard specimen. So in that indication we have seen that if that bar will go to upward, this the moldability properties of the molding sand is good. If below that line the molding properties of the sand is not good. Now we preparing the standard specimen of the molding sand. Finally we have prepared that molding sand specimen. That is the 50 millimeter to 50 millimeter sand specimen, and using that sand specimen we measure the compactability test. Again we doing that process, and after ramming that sand specimen also we measure the compactability percentage. Using some devices we remove the extra material from that particular tube. And after ramming using some scale we measure the compactability percentage. And using that video shows the compressive strength, how to measure we compressive strength, shear strength of the foundry sand, how to measure. That is the compressive strength machine, universal sand strength machine. By using that machine we measure the green compressive strength, shear strength, tensile strength, transverse strength, higher range of the compression strength with high strength attachment. We measure using that universal sand strength machine. From one machine using that thing we have measured. First we prepare the one standard specimen, 50 millimeter height and 50 millimeter diameter. That is the universal sand strength machine we are taking. That is the universal sand strength machine, and that is the compression pads. Here we kept the standard specimen, and that is the control unit. That is the control unit. First we are taking the standard specimen and kept to that particular strength pad. Then we provide the strength, and after providing the strength it will take crack. Means when it will take cracking, so in that time we take the reading, and that reading shows the compressive strength. Now we measure the shearing strength. Some attachment we have changed, that type of attachment we are taking and also attached to that particular compressive strength machine. Then we kept the specimen. There is a control unit. we reset that for measuring the compressive strength. Now we are keeping the standard specimen, then we press, and finally we have measuring the shearing strength of that particular standard specimen. It will take cracking, and that is the shear strength of that particular molding sand. Using that machine, we measure the 5 type of things of the molding sands. In case of using that video, we have showing that using that video we measure the Sator index and Sator index numbers. What are the process? Using Sator index process, we measure the, for measuring the, means it will indicate the sand stiffness. What happened? In using that process, we measure the sand then toughness. So we taking the standard compression test cylinder, okay, and we take the test specimen, we kept here, we kept in that position, and after the height of that, from that position to that position, that is the 1.83 meter, and that sheep, the mesh size is 13.2 millimeter, okay, and here we falling down of that particular specimen to that particular sheep. After falling down, some materials will be received to that particular sheep, means some extra materials will be kept to that particular sheep. Then we are taking the weight of the materials which is kept to that particular sheep. We taking the weight of that remaining material to that particular mesh size into 100 by total weight of that particular specimen. Using that things, we find out the Sator index. That will shows the Sator index. Is lower value of that indication core lift, okay, and in case of higher value also of that particular sand also it is not satisfactory. So values from 50 to 85 represents the moldable range in that molding sand. So in that video we are showing the type of different cores. Means core will be used for producing the internal features to the particular sand, particular casting process. Means here core will be kept horizontally. One part kept to the cope of the molding, other part kept to the drag side. That is the core. Horizontal core, that is the horizontal core. Means the position of the core are kept horizontally. The core placed horizontally. Means half part will kept to the cope side, half part will be kept to the drag side. Final component, that is the produced final component, and internal portion is the hollow portion. Vertical core means the position of the core is vertically. Mold, vertical is beveled at the top and bottom of the surface for locating the core vertically. That is the final product. Balance core means half part of the core will remain to the cope side, half part of the core will be remain to the drag side. Supported by only one core pint. Only one core pint we have used for supporting the core to that particular balance core.